Hey, how's it going, guys? In today's tutorial, I'm going to be covering how to get your Raspberry Pi set up from scratch. This will be my take on how to get your environment and hardware properly set up in order to help you follow along with some of the other tutorials featured on the channel. My goal for today is trying to get you up and running as quickly as possible while keeping development and prototyping in mind, as well as following best practices. So before we get started, I just want to let everyone know that all the components featured in this tutorial can be found in the description below, and I'll have a detailed write-up on my website and also post that link in the description as well. So moving on to the hardware, in today's tutorial, I'll be using a Raspberry Pi 4 starter kit provided by CanaKit. So I highly recommend that you purchase your Raspberry Pi in some sort of kit. In that way, you will be guaranteed to have all the accessories and be able to set up your Pi successfully. Sometimes if you're missing an accessory or two, it may complicate the setup process. So talking about a few of the components provided in the kit, I just want to go over some tips and tricks as well as some issues you may encounter. So focusing on the micro SD card, the micro SD card provided in this kit comes pre-installed with noobs, but I'm going to be actually showing you how to flash a fresh OS image. And this is useful because, it will allow you to have the latest and greatest, version of the OS, and it's a little bit quicker to set up in my experience. Also, I'll be showing you some tips on working with a boot drive directly, so that way if you want to go the headless approach, that'll be very helpful for you too. And then touching on the power supply, so the USB type C power supply that's provided in the kit is fairly reliable, and it's been rated for the Raspberry Pi. So I know on the first generation of the Raspberry Pi 4, people have been having issues with third-party USB Type-C power supplies. I don't know if that has been addressed. So you just want to make sure that your power supply has been rated for the Raspberry Pi 4. And this is especially important if you start plugging a lot of sensors and components into the Pi, because all of those sensors will consume more power. And if you don't have enough juice, so to speak, that's provided by the power supply, you may encounter some issues. So moving on to cooling, the kit also contains aluminum heat sinks and a fan. So just just to note that the Pi has been designed to run without heatsink or a fan. It'll actually down throttle the CPU automatically if it overheats, and the heatsink and fan is more optional and based on your use case. I prefer to run the heat sinks whenever possible and then only run the fan when I need to use it, but this is totally up to you. And then finally, touching base on the case. So I prefer to put the Pi in the bottom piece of the enclosure and then work on different prototyping and development. And then once everything's finalized, then you can button it up and put the top on. It's also good to insulate the bottom so that the leads don't get shorted or anything on your workbench. So yeah, that's just my quick rundown on some components provided in the kit and some things you should keep in mind. Let's talk about the physical setup process now. So the first thing you want to do is take your Raspberry Pi 4 out of the anti-static shielding and place it in the bottom portion of the enclosure. After that is completed, go ahead and attach your aluminum heat sinks to the CPU as well as the chipsets. Then moving from there, you can attach your USB mouse and keyboard to the USB 2.0 ports, and then attach your micro HDMI cable to the first port here and the opposing end to your TV or monitor. Then you can break out your USB Type-C power supply and plug this end here to the receiving port, but don't plug in the brick to the wall just yet. Also, you can hold off on plugging the fan and the top portion of the enclosure, as we can leave those towards the end of the setup process. Now you're ready to proceed with flashing the micro SD card. So go ahead and take your micro SD card, plug it into the USB adapter, and then plug your USB adapter into your personal computer or desktop. So I hopped onto my desktop and opened up a web browser. So there's a few things that we need to download before we can get going on flashing the OS. So just a note, I will leave all the links for these websites in the description below. The first place you need to go is blana.io/etcher and download the Etcher utility, which will allow us to flash the new image onto the micro SD card. So just click the download button for whatever operating system you have. Um, you'll download the installer file, and then once that's done, go ahead and install that to your OS. When that's complete, you can move on to the Raspberry Pi.org/software/operating systems website, and this is where we will obtain the new Raspberry Pi OS image. So you just want to navigate to the first one on the list here, Raspberry Pi OS with desktop and recommended software, and click either the download link, which will directly download it from the website, or alternatively download the torrent and download the torrent file. So in my experience, the torrent approach is a little bit faster, so you may want to take that into consideration and go with that approach. So I've already gone ahead and downloaded the .img file. So it'll appear like this. This is what I have on my desktop. So if we open up Etcher, you should be presented with a prompt similar to this. So basically the process is as follows. We're going to select this file. We're going to click Flash from File, navigate to the image file. Then we're going to select the micro SD card that's plugged into your computer, and then click Flash, and it should handle the flashing procedure. So let's go ahead and do that. So just make sure my micro SD card is plugged in. Click Flash from File, navigate to the file itself here. Hit open, select target. So I have the 16 gigabyte flash drive right here. Click that and hit select, and then now you should be ready to go. And if you click flash, it should start with the procedure. So as you can see, it's flashing. It may take some time, but yeah, just be patient and it should be over soon. Okay, so the flash process was a success, and you'll be presented with this success message, and it'll ask you to flash another image. So just go ahead and close this out at this point. So now you want to just safely eject your micro SD card USB adapter and then plug it back in physically. So just go ahead and do that. And now you should see a boot drive message pop up when you plug it back in. So go ahead and open up to view the files. So you'll be presented with a bunch of Linux files here. So now I'm going to be talking about setting up the Raspberry Pi in a headless fashion. So the next step is optional. So let's say at this point you wanted to have your Raspberry Pi boot up and connect to the Wi-Fi, and then also be able to connect to it remotely without the use of a mouse or keyboard and display. So the first thing that you're going to need to do is create a SSH file, like a text file that's empty, and also a wpa_supplicant.conf file with your Wi-Fi credentials. So just to note that these files will be provided on my website, and the link will be in the description if you choose to follow this approach. So opening up a text editor here, you can see that the WPA supplicant has this network block, and right here is where you will replace your actual Wi-Fi SSD and password pair, and then the SSH file is just empty. So after you make the edit to this file, you can go ahead and copy these two files to the boot directory. So what this does is when the Pi initially boots, it will see the blank SSH file and enable that feature, because by default it's set to be disabled for security reasons. And then also it will inspect this WPA supplicant file and then pull in your Wi-Fi credentials, and it will try to connect automatically. So at this point, you can go ahead and safely eject your micro SD card and plug it into the Raspberry Pi. Okay, so I took my micro SD card, put it into the Pi, and plugged the power supply into the wall. So this is what I was presented with on boot. You should be presented with something similar. If you went ahead with the optional headless setup, you should be already connected to Wi-Fi. So I set my credentials off screen here, and I'm connected to my test network Pi-Fi. This warning message we can see here, SSH is enabled by default and the password Pi user has not been changed. So it's good practice to change the default password, as there are several botnets that I know of that will just kind of probe to find Raspberry Pis and then sort of infect them and do malicious things to the Pi. So it's best practice to change your password on a fresh install. So we'll go ahead and do that. You'll be presented with this, what do you call it, welcome guide. So this will kind of walk you through the setup. I always just close this and go and open a terminal. So I'm going to show you my approach. So open up a terminal. There's that little terminal icon I clicked up here. What we're going to do is type sudo raspi-config. Actually, before we do that, we need to update and make sure we have the latest updates for the OS. So we do sudo apt get update. Okay, so that's done. So now we can proceed with the other commands. So sudo raspberry config, hit enter, and we presented with this menu screen. So the sudo raspi config is very helpful to set up the Raspberry Pi. It allows you to change network settings, boot options, enable different protocols to communicate. So we'll just kind of walk through the basics here. So the first thing you want to do is change the user password. So we'll just select item number 1, and then we'll just give it a simple password, but you should probably use a strong password. So I'm just typing password here. So password changed successfully. So then another thing too is if you didn't go with the headless option, you can also put in your Wi-Fi credentials here. But I'm not going to get into that right now. So yeah, and option 2, we can change the host name of the device. So by default, it's set to Raspberry Pi. So if you wanted to do something specific, like name the device, we can call it, for example, test _ Raspberry Pi, and hit that. Localization options. So this is like changing your time zone, like wherever your region is. It might be off, but yeah, definitely go ahead and check these settings and make sure they're properly set. And then one of the more important options is interfacing options. So if we go here, this is where you'll need to definitely check if you're prototyping and developing stuff. So the headless setup, we've already set up SSH, but if you haven't, you can enable it here. VNC I'm actually using right now just to display and screen record. So this allows you to remote into the Pi, but also have the GUI interface. So SPI is a software-based serial. So if you're working with some component, this is what you'll need to enable. I2C, if you're working with a sensor or component that uses this communication protocol, you should enable this as well. Serial, I think this is just the shell and messages. So depending on your serial setup, you may have to toggle this feature. But by default, I believe they're all set to off. The most important ones, in my opinion, is definitely have SSH enabled, because you will want to remotely access your Pi. And then if you have a camera module, you can enable it here too. So then once that's done, you can go ahead and go back. Overclocking, if you have like a use case where you need to squeeze a little bit more performance out of the CPU, this is where you can overclock your CPU. Advanced options, just some other things you can go through and tweak here as well. So after that's done, you can hit finish and then reboot the device. I'm not going to reboot because it will affect the recording here, but definitely after you've made changes, go ahead and reboot. So just walking through the OS real quick. If you need to edit some code, you can hit the Raspberry Pi icon, go to programming, and then there's several different IDEs. You can use Genie or Thonny. I prefer using Thonny on the Pi. If you need to quickly edit a Python script, you can just we can do here print hello world. I'm gonna see if we can run this. I guess we need to save it first, so it's like .py, and then yeah, so you save the file and then run it, and it will just run the script. So that's one way you can interface with Python on the Pi. Another way is to do it directly in the terminal. So we can do Python 3 -s version real quick to determine that we're using Python 3.73. And if we hit Python 3 and just hit enter, we'll enter idle, and then we can do the same thing. It should return the result. So that's working. Let's just exit out of this. So yeah, so at this point, you're pretty much set up with your Raspberry Pi and have everything squared away. So this concludes the Raspberry Pi 4 setup process. In the future, I'll be coming out with more content to go over some more tips and tricks working with the Raspberry Pi OS. Leave a like and subscribe, and stay tuned for upcoming videos. Peace.